Hi, everybody. Welcome to the Shiko SAT review series. And this will be our last video to talk about a system of equations. In this video, we're going to talk about, how to find the coefficient in front of the system of equations when the system has no solution. This is a very confusing topic. A lot of students lose the points and for this type of the problems here. So we are going to talk about how to find the constants or coefficient in front of the variables. Okay, so if you take a look at the previous two, so this is our first video. So we just talk about how to use elimination and substitution methods, try to solve the system of equations. Then this is our video 2. So we talk about if your system of equation, the coefficients in front of the x, y have fractions and decimal, how to do that. And also we cover like the 3 problems here. How about if the system of equations is not linear anymore? If they include the quadratic, then how do we solve it? So remember we talk about in the video number 2, we say what the factoring scheme is very important, right? So this is our last video. And like I mentioned before, this topic, many students that are confused. So we're going to have 3 problems. We're going to work on that. So for these 3 problems, they give us a system of equations. Then inside the equation, some of the coefficients are, like not given, right? So now we want to say what the value will make this system have no solutions here, okay? So that is what we're going to focus here. All right, so now let's go to the whiteboard and take a look at how do we do those type of the problems here. All right. Okay, before we do this unit, and I'm going to do a very brief review about the system of the equations here, right? So in here, we said about the system of equations. Okay. All right. Okay, so I'm going to talk about the first one, if when we talk about we have a unique solutions. So let me say I have 2 lines. So let me use here. So for example, this is my line number 1 here, right? And then I have this one here. I have line number 2 here, right? Okay, so this is, I say, is line number 1. This is line number 2 here. So if they intersect at a single point, that's what we say they have a unique solutions here. So basically, so sometimes here, that's why your line and 1, you can write is ax plus by equal to EC, and then you can say that line 2 will have like some like dx plus EY equal to F here, and you can solve the system of equations XY. That's what is intersect at a specific point. Okay, so when we talk about the no solution, what is the no solution means here, right? Okay, so the no solution, that means I have a line here. And I have different lines here. All right. So this is my line number 1. This is my line number 2. When we talk about the system of no solution, that means this L1 is parallel to L2. That means they're never going to intersect. So that's why it's no solutions here. So what is the characteristic of no solution? Okay, so if line 1 is here, right? So if line 1 is here, the equation is ax plus by equal to c. If line 2 is parallel, so we know what the parallel means, right? The parallel means they have the same slope. That means line 2 is here. The coefficient in front of here, they're only going to be different by a numbers here. So for examples here, what I mean different by a number, that means it will be a constant Ka(x), right? So Ka(x) plus what? Kby equal to some C star, some different C, and here the C is not equal to C stars here. So this is kind of like the key things. So that means where C is not equal to C star. That means the front two equations, like these two equations, these two coefficients, they are proportion. But these two, they are not proportion. Then it cannot happen. So that's why we say it's no solution. I'm going to show you how do we do this. Okay, so now the next one's here. Okay, so the next one's here when we talk about, the no infinity solution. So let me see if I have a line here. Okay, then I have another line. Okay, so that means this is line number 1 and then line number 2. As you can see, I overlay them, right? So that means it's an infinite solution. That means that every point is intersection point, right? Because these two lines overlay each other here. So when you write down the equations here, that means if your L1 is equal to the ax plus by equal to c, then your L2, the only difference here, they can be different by a constant here, kby and kc. So that means they all what? They all proportions, right? So A and the Ka proportion, B and the Kb proportion, C and the Kc proportion. That's what we mean, the 3 possible, right? The unique solution. So like in here, we practice in the video number 1. So you can use the elimination or substitutions, right? We did this, how to find it. Now we're going to talk about how to find the no solution or infinite solutions here. So ready? Okay, so now let's go to see our problems here. Okay, so the first problems here, they said, okay, find the value of A, which has no solutions here, all right? Well, so for when you try to do this type of problems here, remember, right? So we said if they are, the different bio proportions, right? So you can do 2 different ways. I'm going to show you one way. So here, then we can do I'm going to show you both ways to see which way you prefer, right? Okay, so here, this is negative 3x plus y equal to 6. So this is ax plus 2y equal to what? Equal to 4, right? So you say, from we just discussed, if they are proportions, right? So here is 2y, 2y. So in order to be proportions, so what I need to do here, I say, hey, let's times 2. Oh, here, right? So if you times 2, so this is negative 6x plus 2y equal to 12. And this is ax plus 2y equal to what? Equal to 4. And then in here you say, okay, this is good. C1 is not equal to C2, right? They are not equal. So this is a proportion. So this is 2y. So what is my A has to be? So what is my A has to be? So A has to be negative 6. If A is equal to negative 6, then this 2, so what is this 2 turns out to be? So the first equation turns out to be negative 6x plus 2y equal to 12. Then the second one is negative 6x plus 2y equal to 4. So based on, so if you go back to here, right? So these two, you know, they proportion. But here, the last one here, the constants, right? The constants is not a proportion. So I know what? I know that has no solutions, right? So A equal to 6, negative 6. Or you might say, well, I don't like that, right? So that's fine. You know, so you say, well, I don't, you know, this one seems, I don't know how to, can I just solve it? I said, yeah, absolutely. Okay, so let me show you how do we, you know, if you just want to solve it, right? So you say this is 2y, this is 2y, this is y. Okay, so I'm going to do, this is negative 3x, right? So let's try to break it. Then you can make a decision to see which way you like. So this is negative 3x plus y equal to 6. Okay, so what I'm going to do here, because I want to eliminate with y, so I'm going to times what? I'm going to times negative 2. All right, so when I times negative 2 times negative 3 is what? It's 6x minus 2y equal to what? Equal to negative 12. Now I carry over my second equation. This is ax plus 2y. So this is the one you're probably familiar with. Then we did a lot of elimination methods here, right? So you plus, so boom, boom, these two cancels, right? So this will be a plus 6 to the x equal to what? Negative 8. Then you divide by a plus 6, divided by a plus 6. So what do you have here? So the x equal to negative 8, a plus 6. So the only way the x will not going to make is if the denominator equal to zeros, right? So I know the denominator cannot be equal to 0 in order to have a solution. So the only thing that x has no solution is a denominator equal to 0. That means a plus 6 equal to 0. So what is a? Negative 6. So you can have a two-way to solve it. Did you get that? Okay, so you can have a two-way to solve it. And then when you have a two-way to solve it, and then you know they get the same answer to whatever you like. Or you can match the constants, right? So you can match the constants. So now let's take a look at the second ones here, right? So the second problem is here. Let's see here. I want to find the value of k. So the system has no solutions here. So let me erase this statement so I can have a little more space to work on. Okay, so now here, okay, so here I said, okay, I'm going to go back to what? I'm going to go back to here. I want to match the constants here to see at the end they match or not. If they are not matched, then I know there's no solutions, right? Okay, so the constants I know here is negative 3, negative 5. Well, all right, so how do I match it? Then you said, okay, so maybe, okay, so here, if I times this is 5, I times here is 3 is here. Why? Because 3 and the 5, the common multiplier is 15, right? So now I can have the common factors here. Okay, so if you times 5, let's take a look at what it's going to be. So the first equation will be 5kx minus 15y equal to 20. All right, then the second one here, this is 12x minus 15y equal to what? 35. Wow, okay, so first things you see here, you know, this is the first thing you see. You say, hey, 20 and 35, they're not equal. That's good, right? See here. They're not equal at the end. That is no solution, all right? They're not equal, so that's good. Now, my front has to be, my constants has to match, right? So 15y minus 15y match. That means what? That means these two has to match, correct? All right, so that means what I have here, that means 5k, what, equal to what? 12. Good. So what is the case here? So you divide it by 5, divided by 5. So k is equal to 12 over 5 here. That's our solution here. So when k equal to 12 over 5, all the coefficients in front of my x and y are matched. But my number doesn't match. So this one here does not match. That's good. That means I have no solutions. Okay? Okay, so now let's take a look at the last ones here. Last one is interesting one also. So here you said 3, 4x minus 1 half y equal to 12, ax minus by. Okay, so I have it here, x minus by equal to 9. All right, so I want to see if there's no solution. Now, what is A over B? Well, I need to solve the A and B's here, right? Okay, so the first thing here, you say, okay, I'm going to take a look. I do not like fractions, like we talked before. You know, let's simplify it. So this is 3/4, 1/2. Hey, let me times what? Let me times the 4 on both sides here. All right, so I times 4 on both sides. Let's see what happens. So my first equation is here, 4 and 4. So you got a 3x minus 2y equal to 48. Now you compare, you put your second equations here. So this is ax minus by equal to 9 here. Okay, so first thing you see, 48 and 9 is not equal. Now here, the 3x minus 2x, here's got a negative sign. So that's pretty good. So I know A has to be some constants of 3's, right? So that's why the A over B. So if you compare, A could be 3 and the B could be what? 2, right? Because negative B, negative 2. Because A can be like, if you go back to here, is the some constants times A, some constants times B, right? So now in here, you will say here, you can say this really is A could be some like 3 times K and 2 times K, and then the K and the K cancel. So that's why this is 3/2. Right, so that's why the ratio is 3/2, and that is your solutions here. Okay, so that's it. And so when you try to solve the system has no solution. So it's your constants term will not equal. If a constants term equal, then you will have an infinite number of the solutions here. All right. So that's why in here we need to be careful here, right? So you need to remember like what my review here, right? So here, if they have no solution, that means your coefficients of x and y, they can be proportional, but the numbers of the constants at the end is different. But if they have infinity solution, that means the whole, all these 3 numbers, A, B, and C, will be proportional. So those are the 3 problems, you know, try to find the value. The problem really is kind of like it's a quick, easy, you know, it's a quick calculation, but you need to understand the concept. Like I said, this type of problem, many students got confused and lose points during the tests here. So make sure you understand the concept and why I try to match the constants here. All right, so that's it. So for these 3 videos here, and basically cover all the system of equations from the SAT exams and the things you need to be careful and you need to be aware of it, right? So like I said, the SAT is a timed test. So the problems typical is not going to be hard. And you need to know the different technique, or some people call tricks, to do that. So when we try to find a no solution, the techniques here is try to match the coefficient for the x and the y's here. All right. Okay, so that's nice to talk to you for this unit, how to solve the system of equations. And I hope that, after review these 3 videos, you will have a good idea and you should be able to solve all kind of system of equations from the SAT exams. All right, good luck. If you like my videos, feel free to subscribe to my channel. And also, if you still get confused, you can leave me a comment and I will answer your comments here. Okay, so nice to talk to you and good luck, when you take the exams here. All right? Okay, bye.